There you go. Hello. Hi, I'm Matt with Schematical, and in the dark tonight is Dominic DeMarco. How's it going, Dom?
Happy Tuesday. You know, those street
Well,
lights are usually on by now, and I don't know what's happening.
you are known for your scenic backgrounds, so I'll just have to take your word for it.
Mm.
But how's it going other than that?
Keeping busy, working on some interesting projects, and I just had a very nice ramen for dinner tonight.
Yeah, wonderful. Well, unrelated to that, let's talk about DynamoDB's new vector indexing capabilities. So I've told you about vector indexes,
Mm.
but if you don't mind, I'm going to recap just a little bit for people. I
And,
said
and
reason.
also briefly touch on horizontal scaling built in and why
That
that's
is,
important.
I haven't figured out how they're doing that one yet, so I'm impressed. So the concept of a vector database is relatively new. What they do is they take an AI model that will basically convert. Let's just say the example I've been using a lot is with images. You could take an image, a bunch of images of torn biceps. So last year I tore my bicep from the bottom. It's not uncommon. From the forearm, but it's not uncommon to tear it from the top. And so what you could have done is you could have fed in all these images to a model, and you could have assigned them a score of how torn they were. You know, like 10% torn, fully torn, not torn at all. That would be your x-axis. Then on
Would
the
that be would that
y-axis,
be data provided data for
yeah,
training?
you'd have to have radiologists classify that. So they would give it a score on how torn it
Mm.
is, and that could be represented on the x-axis, and then the y-axis would be,
Mm.
was it torn from the top or torn from the bottom. And so you feed this into the training playground to train a bunch of AI models on all this data, and then what you would do is you'd feed in at the end an image that it hadn't classified, and it would then classify it as either torn or not torn. You know, they give it a
Mm.
score that way, and then tell you if it's top or bottom, basically. And so that's how vector databases work with images. You can do the same thing with word blocks. So you can give it a series of words, and what it'll do is instead of just an XYZ,
Mm.
you can have thousands of dimensions. So one of the dimensions might turn out to be sentiment. Another dimension might turn out to be um, warm, cold, or styled, you know, something like that. But then you end up with these interesting things where it learns that different words are associated and mean different things. And if you train it with enough data that's even like got spelling errors in it, or you know, it can recognize synonyms. So basically, it's some
Mm.
technology we haven't had before. Up until very recently, if you did a string search, it was, you know, very straightforward. It was the exact string match, or you know, you'd have to program in
Mhm.
specific rules to say this before
Very
this, but
literal.
not after this.
Mhm.
Sorry, go. Okay. And so this technology has made it so it actually has some reasoning to it. And then there's not just one type of model. I'm sure they're training medical specific models, legal specific models.
Mm.
You know, and then there's probably your more generic ones that are for more social and friend stuff. Would
Mm.
be amazed if they weren't training technical models. So what you do, like what I just did, I'm doing a code and learn type thing for a podcast coming up that I'm a guest on, and so I created one of these DynamoDB vector databases very easily,
Ah, okay.
and using AWS, and fed in all the knowledge base is my writing, and then now my bot can now access that to query my knowledge base and learn things about me. So when
Mm.
I when I say, hey, what's that piece I wrote back 2 years ago about this topic, it could pull it up for me because Google doesn't do a great job with that.
Well,
The
could it also help you
indexes.
mine for new topics?
It could.
What if
It
you
could. You
over
could use
what
it
if
for
you overlay
brainstorming.
your what if you overlay your analytics on top of it?
That would not be a bad idea either. I could tell you that
Mm.
my most visit posts are some random posts about some random Redis thing that Google caught
Mm.
on to, and people evidently read that. But that was from like 4 years ago or something. It's painful.
Mm.
But this technology is pretty amazing. And as you said, they're boasting that they can horizontally scale. Now, for those of you
Mm.
guys that don't know, if you vertically scale, you basically end up with just you doubling your costs every time you scale up, and that can be extremely expensive and cumbersome. But horizontally, using sharding partitioning, which I talk about a lot on my YouTube channel and whatnot, you can scale incrementally. So let's just say that you had 3 instances and you wanted a fourth one. You're only increasing your costs by, not double, but by
33%.
25% there, 33% there. And so it's really nice for that. It's nice for speed. It's great for that. So and Dynamo comes with that kind of forced on you by default. So I'm very curious how they're doing the vector math to make that partitionable, because what you have to set it up a certain way. There are limitations on the way you structure your data, but once you embrace those, the scalability of the data becomes damn near infinite. It's incredible. So I was pretty excited to see this. I don't know, we can jam on this for a minute, but on a side note, I mean, I think a lot of people are putting huge amount of faith in these LLMs, or these, what are they called? Embedding, these, not the embedding models. That's actually what I like, these big flagship models that are being pushed out by Gemini and whatnot. And I think there's so much more opportunity to be made in these kind of niche use cases like this one, because under the surface, people don't realize it. But like when you asked an LLM, hey, tell me the latest this, that, and the other, the LLMs, the knowledge it was trained on is cut off, let's just say 6 months ago. So the LLM itself has very little knowledge of what's happening currently. The way it sees the world a lot of times is that it makes a tool call out to one of these vector databases, which has, gone through and taken the latest information and,
updated every hour.
Yeah, and created a multi-dimensional index for it, in which case it gets that information via this. So the LLM actually is not that intelligent. The interface, the big model you're talking to and paying all the GPUs for on Claude or whatever, they pretend like it's intelligent, but the way it sees the world, or it accesses its memory a lot of times, is through these vector embeddings. And so those are so much more powerful, in my opinion, long run. At least, I mean, that's where there's less competition in the market right now, because everybody's trying to train their own AI models. But you could, use a lot of these existing vector embedding models to do some pretty cool stuff with, or you could, train your own, like I said, to be a specialized, radiologist type model, bicep torn, not torn. Am I losing you? I think I'm losing down. So right when I end my rant, so I think there's a lot of really amazing stuff to be done with this. And another thing is, I believe it's going to, I don't want to say replace classifier models, because there's going to be a use case. I think the divergence there'll be a use case for fast, quick, small classifier models. But when you're talking about big thinking tasks that you want to be able to find outliers and be up to the minute with, you're going to see more of a vector index type use case for classification, similar tasks. Again, like I said, classifying torn, not torn. So Dom is enter the studio. Let's see if I can get it back on stage. Hey, you back? Oh man.
And I think I froze immediately. I've got 4 bars of 5G. I don't know what's going on here.
I don't know either. With that said,
okay, carry on without me.
No, you go ahead. You got any thoughts real quick while I got you? And he's gone.
We're not having good.
That's all right. I'm just going to roll with this and wrap this one up. I'm bullish on this technology. Other technologies I think have been overblown. This DynamoDB is one of many things. They've got vector indexes on S3 now. I mean, they're slapping on everything. I did it in Mongo a while ago. I did something similar. So everybody's adding these vector indexes, and they're very powerful. So if you haven't used them, if you're just still doing the old-fashioned text search, and that's how you're giving people access to your data, that's good, but you're kind of being left in the dust. And these new models can extrapolate some interesting patterns with your data that like an LLM or something like that couldn't quite do. So I would recommend checking out this technology. And if you're interested in learning more about that, I write about this. Check out the mailing list, check out the community. I also consult on this stuff. And like I said, I am the guy that they're coming to design how this stuff would work on AWS. and run it. So listen, subscribe, and I'm sure you'll be seeing that one coming down the pipe. I think it gets filmed in September. So registration, once I get the registration link, I'm sure I'll send that out there. But if anybody wants to learn more how to do this hands-on with AWS cost effectively and securely, please check that content out. With that said, I'm Matt with Schematical, and have a great day.
See y'all.